Well, I'm glad to see you're doing homework over spring break. It makes my heart sing with the joy of physics. But for starters, I wouldn't ask ChatGPT or any current AI engine for help with physics. I've tried them on some fairly basic questions that often have a bit of a trick to them, and they seem to right now inevitably be getting them wrong. So, hey, human brains for the win still. They are getting better, but I would not at this point go to an AI engine for high school physics help. Unless the question is a straight plug-and-chug question, then they might get it right. So in Lesson 6, we were looking at friction, and we were looking at situations where there was often a normal force that wasn't equal to mg. Number 4 and number 5 are basically clones of the same question. So you had said you were having trouble with these. I'm going to do number 4. I'll let you try number 5. But what I'm going to do is I'm just going to change the numbers in number 4. I call it cloning a question. So I'll show you what I mean. I'll paste it right here. Close that little window. Scroll down. Instead of 120, first of all, instead of the mass being 16 newtons, I'll make it 16 kilograms. I'll make it 19 kilograms. Instead of a coefficient of friction of 0.42, I'll make it a coefficient of friction of 0.35. And instead of 120 newtons, I'll make it 193 newtons, which means this answer is going to be wrong. This way, you can still try the homework yourself. They want me to find the acceleration. I don't see a VI or a VF. And in fact, what I'm going to be using, I actually pasted the equations from my formula sheet. I have a feeling I can narrow down to which 2 or 3 common mistakes you're making, but I'll let you have the aha moment yourself. This is a job for a free body diagram. Although since they gave me the picture, I'm going to label the picture. What are the forces acting on it? So we have gravity down. Is it sinking to the ground like quicksand? No. Is it flying into the air like Superman? No. So the normal force is the same side as gravity. Now, that's not going to be the case if there's an extra vertical force, by the way. Coming down the pipe, like in number 6, there's an extra vertical force. The normal force won't be the same size as mg, and it's not 12 newtons. I'm going to have to figure it out. We'll get to that. But let's keep going with my clone of question number 4. We have this 193 newtons. This is the mystery force coming from off the page. We've typically decided to call that F applied. And there's a coefficient of friction. I don't want to move that around. There's a coefficient of friction. So we're going to have the force of friction. Now remember, this 0.35 is not how you calculate friction. Friction is mu times the normal force. That's going to be friction. First of all, who's winning? I think we're accelerating to the right, so I'm going to assume that F applied is winning, and my equation is going to be winner. Looks like friction is the loser, equals MA. Friction is mu times the normal force, so I can say F applied minus mu times the normal force equals MA. So one common mistake that kids make is they forget to put the normal force in for friction. They just put the mu there. They say, oh, friction is 0.35. No, it's 0.35 times whatever the normal force is. I don't know the normal force. In this case, the normal force equals mg. In this case, those two are the same size because we're not accelerating vertically, which means vertically forces must be looking forward, starts to let it be balanced. So on the next line, I also could have divided by m. I could have done that on the previous line to get the A by itself. I named that after someone in your class. I can't remember who I named it after in your class. So we get the acceleration equals F applied minus mu. Instead of the normal force, I can say mg over m. And now I can plug in my numbers. It's going to be 193 minus 0.35 times what I say the mass was in this question, 19 times 9.8. divided by 19. I have no idea what the answer is. 193 minus 0.35 times 19 times 9.8, close bracket, divided by 19. And I get it's accelerating, if I type this incorrectly, and I think I did, that's good, at 6.73 meters per second squared. So that should get you through number 4 and number 5. By the way, the other thing I could ask you is, instead of asking you to find the acceleration, I could give you the acceleration, and I could ask you to get the mu by itself. How would I do that? We'll get there. But those are the big two. I'll either give you the coefficient of friction, and I'll ask you to find the acceleration, or I'll give you the acceleration, and I'll ask you to find the coefficient of friction. You'd start out the same way. This is a job for a free body diagram. And then you would do your winner minus loser equation. It's just then after that what you choose to get by itself using formula manipulation. So I'll leave you that for number 4 and number 5. Let's move on to number 6. You'll notice there's an extra vertical force up. And in number 7, you'll notice there's an extra vertical force down. So I'm going to do number 6, and same thing, I'm going to clone it. I'm going to change the numbers. So instead of lifting up with 12 newtons, let's make that 14 newtons. Instead of pulling with 44 newtons, we'll pull with 48 newtons. Coefficient of friction, I'll make it 0.63, and let's make the mass 3.9 kilograms. So now it's a whole new question. All right, they want the acceleration. This is a job for a free body diagram. I'm going to label the forces. Let's see. We have gravity down. Now, there's an extra vertical force. Someone is lifting up. Normally, the normal force has to cancel out all of gravity. But something is lifting up with 14 newtons, which means the normal force, which, remember, is the ground pushing up. The ground is not having to push up as hard because it's not having to cancel out all of gravity. Something is already taking care of 14 newtons worth of gravity. So the normal force is going to be smaller than gravity. I'm going to draw it like this. Now, if you're having trouble understanding why it's smaller, here's what you do need to realize. Are we sinking into the ground like quicksand? No. Are we flying through like Superman? No. So there is going to be a normal force, and what really this means is vertically forces are balanced. It means everything down has to equal everything up. And in fact, that's an equation I'm going to write in a second. I'm going to say, first of all, let's finish up. I have F applied. This 14, you could call it another F applied. I usually just leave it labeled as the 14 and say, I notice something's pulling up, and friction. Who's winning? F applied. Who's losing? Friction, because we're going to walk along this line. So it's F applied minus friction equals MA. In fact, the same equation we had for number 4. This is just going to be a bit more complicated. They still want me to get the A by itself, so I can divide by M. And I'm going to get A equals F applied minus mu times the normal force, because friction is mu times the normal force. The normal force is not mg. I'm going to figure out the normal force in a little box right here, but I'm going to get rid of the box. How can I figure out the normal force? Because there's extra vertical forces. It's not mg. What I can say is, since we're not sinking into the ground like quicksand, and we're not flying into the air like Superman, everything down equals everything up. Everything down, mg, equals everything up. The normal force and the 14. How would I get the normal force by itself? I would subtract the 14. The normal force is going to be mg, take away 14. And now you have a choice. If you wanted to, you could quickly crunch that on your calculator. M is 3.9, so you could go 3.9 times 9.8 minus 14, and you could say, okay, the normal force is 24.22. Carry all the sig figs. Or you could substitute this algebraic expression right into there. I do that because I'm lazy. I like to try and do everything in one step on my calculator. So I would write this as, it's going to be F applied minus mu bracket mg minus 14, or 24.22, divided by m. And now I'm good to go. Now I've turned it into I've reached the plug and chug stage. A is going to be F applied. I said it was 48 minus mu 0.63, and then in brackets m 3.9 g times 9.8, take away 14, all divided by 3.9. And so if you want to do this in one step, especially if you got the fancy schmancy fraction button, or if, like me, you like to just show off and do it in one step, it's going to be 45, brackets around the top, minus 0.63, open up another bracket, 3.9 times 9.8 minus 14, close off the mini bracket, close off the top, or down arrow if you have the fancy schmancy fraction button, divided by 3.9. And I get an acceleration of 8.3. You know what? I guess that 9 would round up, so 8.40 meters per second squared. So, in number 6, they're lifting up. In number 7, they're pushing down. Again, free body diagram, you'll still have a normal force pointing up. The normal force is going to be bigger than mg, but even if you're not sure about that, what you'll need to realize is everything down equals everything up. I'll very quickly just kind of, hit the wrong button there, Mr. Duke. I'll very quickly show you what I'm getting at. Let me copy this. Doing this on my home computer, and I don't have it quite as configured for teaching as I do my school computer. So when you did your free body diagram, you would still have the F applied over here. You would still have friction over here. It's still going to be F applied minus friction equals MA. You still have gravity down. You still have normal force up. And everything down equals everything up. mg plus the 12, because it's pointing down, everything down, equals everything up. In this case, the normal force is mg plus 12, and as a bonus, you've already got the normal force by itself. And again, you could crunch it on your calculator, like we did up here with the 24.22, or you could drop the entire expression down into the equation. I think that'll get you through number 6. I think that'll get you through number 7. Number 8 and number 9. Oh, okay, number 9, it's asking you to find the acceleration. We're pushing down. Number 9, I think, is just like number 7, but with different numbers, so I'll let you try that. Number 8 is interesting. They're asking me to get the mu by itself. And number 10 is interesting. They're asking me to get the mu, the coefficient, by itself. And in both of these, it looks like we have an F applied. We have an extra vertical force. The normal force is not 100 newtons. This is just an extra vertical force. This one, someone's lifting up. And in this one, someone's lifting up as well. So I'll take this one, since 8 and 10 are really similar questions, and I'm going to do the same thing. I'm going to just clone it by changing the numbers. There's a bit of a risk when I'm making up these numbers that I get an answer that doesn't work. I may have accidentally made up a question where friction is so big that it's stuck, nothing accelerates, but we'll hope for the best. So let me look at this here. They want the coefficient of friction. You know what? If I pull harder, come back here. Okay, my pen has stopped working. Give me a second while I figure this out. And we're back. So I'll pull harder. I'll make this 65 newtons. Let's lift up with, I don't know, come on, stop doing that. Let's lift up with 90 newtons. We'll make the mass 12 kilograms. What's the coefficient of friction? So again, this is a job for a free body diagram. What are the forces acting on it? Gravity down. Normal force up. How did I know the normal force was smaller? Because 90 newtons of gravity is already being canceled out. The ground doesn't have to push up as hard because someone's already removed 90 newtons worth of gravity. The ground is only having to cancel out a small amount. Again, the key to remember is that everything down is going to equal everything up because we're not sinking into the ground like quicksand and we're not flying into it like Superman. We have F applied. We have friction. Okay. Who's winning? F applied. Who's losing? Friction. Equals what? MA. You'll notice these equations are kind of getting a little repetitive. It was the same equation for all of these. And that's because for all of these, the tug of war was between F applied and friction. Now, they want me to get the coefficient of friction by itself. The coefficient of friction is hidden inside of there. So the first thing that I'm going to do is I'm going to get friction by itself. I'm going to swappy dance. I'm going to plus friction over. I'm going to minus MA over. That's going to give me F applied minus MA equals, and I was going to write friction, but instead I'm going to write mu times the normal force. Because that's what friction is. They want me to get the coefficient of friction, the mu by itself. Hey, what's mu? I don't know. What's mu with you? They want me to find what's mu. How would I get the mu by itself? What's the normal force doing to the mu? It's multiplying. So I'm going to divide. Okay. All I need to do now is figure out how big is the normal force. I'll do that kind of over here because everything down, mg, has to equal everything up, which is the normal force plus 90. The normal force is going to be mg take away 90, which is going to be 12 times 9.8 take away 90. The normal force is 27.6. That's if you want to plug the number down here, or you can plug this entire expression in right there. Either one is fine. I'm going to plug the entire expression in because, as you know, I like to do things in one step. So I'm going to say this. Mu is F applied minus MA all over mg minus 90. It's 65 minus m12 times, they told me the acceleration, 2.6 all over 12 times 9.8 minus 90. Here's where we find out if I made a question that works. Brackets around the top, 65 minus 12 times 2.6, close bracket, divided by bracket 12 times 9.8 minus 90. And I get a coefficient of friction, 1.22. This is a really big coefficient of friction because I made up some bad numbers. But it is what it is. This is what I was worried about when I was making up this question. Had I made up some yucky numbers? Making sure I didn't make any typos. I think I'm good. Let's just try it with 65 F applied minus MA 12 times 2.6 close bracket divided by 27.27.6. Yeah, I got the same thing. So this is a coefficient of 1.22. Usually coefficient of frictions are less than 1. This is a really sticky surface. If you touched your hand to this, when you lifted your hand up off of the ground, you would feel your skin wanting to stick to it. So this would be like, if someone had spilled some Coca-Cola and the Coca-Cola had partly dried, or honey. This would be like touching honey and wanting to stick to it. But the physics is okay, even if I made up some bad numbers. All right, my friend, I hope that helps. I look forward to seeing all of your homework done on the first day back. Enjoy the rest of your break.